Hello everyone. Really glad to be here among this great cast of speakers, so I'm looking forward to hearing what everyone else has to say too. I'm going to talk a little bit more on a practical aspect, but mix in some research that was inspired by the practical aspects of building agents. So hence the title, Lessons from the Trenches on Building Usable Coding Agents. And my kind of underlying goal is to give everybody the ability to communicate with computers and do the things that they want to do. And one of the reasons why I'm working on coding agents, or more broadly software development agents, is encapsulated in this quote by Mark Andreessen from his now classic essay, Why Software is Eating the World, where he says, more and more businesses and industries are being run on software and delivered as online services, from movies to agriculture to national defense. Over the next 10 years, I expect many more industries to be disrupted by software. And, of course, in fact, this is true. In 2025, software is much more prevalent in our life than it was 14 years ago. And so my idea is if we could give everybody the ability to quickly write software to achieve their goals, think about all the wonderful things that they could do. And some examples of this, I know this might be cliche at this point, but if we look at the Nobel Prize in Physics and Nobel Prize in Chemistry in 2024, these were not won by people who are running particle accelerators or wet labs, but rather by people who develop software to better understand our world through training of neural networks that allow us to understand physical systems and for protein structure prediction. I personally am using agents every day to get my work done. This is my personal transition from being kind of a normal software developer to being an agent-driven software developer. And the way I measured this was I looked at all of the pull requests that I made over the past 2 years and checked the ones that were done without agentic assistance and with agentic assistance. And without is blue and with is red. You can notice a few things. Number one, I'm a professor at a university and we don't get to code a lot during the school year. So this is my not happy time when I'm not writing code. But you can notice that this school year, things are drastically different. I'm able to actually write code, get a lot of stuff done. I think part of the reason why is because I can command an agent to do something, and then in my fragments of time that I have throughout my day, I'm actually able to get that stuff done without me really like putting a lot of effort into it constantly. I think this is also going to kind of be a new way of work for a lot of people. Instead of really deeply going into solving a particular problem, maybe going a little bit more surface level, but having AI do a lot of the low level details for you. But anyway, that's a story for a different day. So the software that we're developing is called OpenHands. This is a screenshot of it, but it's a lot more interesting to actually look at it working. This is an agent for developing software, but also doing all the other things that you need to do in order to develop software successfully. So it can also do things like browse the web, to gather information and other things like that. So to give a timely demo, let me see what I should do. Look up the IVADO first workshop on agents and find all of the speakers and their talk titles. Look up their recent papers on arXiv and guess which of the papers will be talked about in each of the talks. Create a BibTeX bibliography for this. So if I send the agent off to do this, the first thing it will do is it'll search the web to try to find the workshop and try to find all the speakers. So it's going through and doing this. And my time is limited, so I'm not going to watch the agent work. So this is a perfect example of me being a little bit busy right now giving a talk. So I'm getting to do this in the background. I'll revisit this at the end. So in developing these agents and actually using them, I've learned a lot of lessons about kind of principles that we should use for building agents. And I'm going to go through 5 lessons that I've learned. The first one is believe in simplicity. I know the bitter lesson is kind of a cliche by now, but this is maybe one instance of this. And so if we look at the rises in accuracy in VersaBench, which is a data set for coding that probably many of the people in this room are very familiar with, you'll notice that we have large gains in accuracy, and then we have kind of a flat period, we have a large gain in accuracy, we have kind of a flat period, large gain, flat period, large gain. Can anyone guess what caused these large gains in accuracy? Yeah, new releases of language models. So there are certainly gains to be had in usability, and some gains to be had in accuracy by coming up with things that are not like new releases of language models. But in general, the large gains in accuracy tend to be based on language model releases. And so if we look at agent architectures, there's a lot of different ways to make architectures. So I don't want to pick on MetaGPT in particular, but this is an example of a paper that came out maybe about the same time when we were first developing OpenHands. And they had this idea of a software company agent that would run the software company, and then you have the boss agent that takes the requirements. You have the product manager agent that does all of the product managing, the architect agent, the project manager agent, the engineer, and the QA agent. And this is intuitively attractive in that it mimics how we as humans work on things. But in contrast, if we look at the OpenHands architecture, it's kind of like this, right? We have like one agent, and it does all of these things. And the reason why I think this is a kind of easier and more attractive way to do these sorts of things is because we're building like an actual agent that people use and contribute to and is maintained and stuff like this. And it's really helpful to not have to maintain 20 agents, but only manage one. So there's that. But also, if we think about machine learning and we think about the bias variance trade-off in machine learning, it's kind of a classic idea, which is when you don't have a very strong learning algorithm or lots of data, you put bias into the model to bias it towards a good solution. But if you have lots of data, you can just learn from the data and be successful. And that's kind of what we're doing here. So they're putting a very strong bias around how a software company should work or how software should be developed, when in reality, that bias might not be correct. Like this software company agent can't go to the Ivado website and download all of everybody's profiles and create a BibTeX entry from it. So because of that, having a single agent architecture makes it a lot more flexible. Based on this, one thing that we thought about in a research paper, Coding Agents with Multimodal Browsing Are Generalist Problem Solvers, is what's kind of the minimal set of tools that we need to create an agent that can solve most of the things that we would like agents to be able to do. And so we approached this by looking at 3 benchmarks. The first one was VersaBench and multimodal VersaBench for software development. The second one was Gaia, which is a benchmark for like gathering information on the web and kind of generally helping out as an assistant. And the third one is the Agent Company, which is a benchmark that we created for basically putting an agent in a fictitious software company and asking it to do lots of different tasks for not only software development, but administration and other stuff like that. And we came to the conclusion that you basically need maybe 3 different abilities in order to do well in a very broad variety of situations. The first one is executing things through Bash. We also give the ability to execute things through Python because sometimes that's a little bit more conducive to agents solving like data analysis tasks more quickly without multiple steps. But probably Bash and file editing are 2 of the main abilities that you need. The final thing is we give it the access to a visual browser and a search API so it can gather information. You might only need a visual browser, but the thing is Google blocks when you go to google.com with a bot. So you kind of need to not circumvent their CAPTCHAs and stuff like that and use a proper search API. So we use an API called Tavily. So we have results in this paper that basically show that with this small set of tools, you could create an agent that does a pretty broad variety of tasks. And all of the papers that had a student or a collaborator leading them have them up there, and that's Aditya. Another thing to point out is, people talk a lot about building tools for agents, but in reality, we also have tools for humans programmers in libraries like PyPy. And they allow us to do most of the rest of what we need. So a second lesson that we have kind of figured out through some of our time is code don't click except as a last resort. And this is based on a paper by a PhD student at CMU, Yuichi Song, Beyond Browsing API-Based Web Agents, if you want to look it up. So there's different ways of solving the same problem. And the first way of solving the problem is kind of the GUI agent or computer use agent style way of solving problems. And the basic idea is we already have a visual interface for humans, and we want to ask the agent to manipulate this visual interface. And so the way this would work is if we have something like open the latest commit log by the user Amy that has failing tests. You might go to GitHub or GitLab, search for the user, click repository, click sort by last updated, and then click the last updated repo, click commits, click, right? All the way until you find something from Amy. And this failed because we ran out of clicks that we were allowed to do. The other alternative is instead you directly interface with the API for the service. And what this allows you to do is this allows you to basically do this in a single program. So you write a program, you run the program, and you're done. And on the other hand, there might be some things where you can't do it with a program because that site doesn't expose an API. So we also proposed a hybrid agent that can do both, but we explicitly prompt it to use programs and then only use a browser as a last resort. And that's what we do in OpenHands as well. So here are the results. And we tried this over a bunch of websites on a benchmark called Web Arena, which was originally created, and actually I guess people have talked about Visual Web Arena. This was originally created for browsing tasks, but we also gave the agent access to the APIs corresponding to the websites. And we see things like on GitLab, this green is the API-based agent, this is the browsing-based agent, and this is the hybrid agent. And we can see that on GitLab, we basically almost triple our accuracy, or over triple our accuracy by using programs instead of clicking on web interfaces. And this, makes a lot of sense. APIs are good for large-scale data processing. They're easy for models to write. They're very familiar with writing Python. On the other hand, there are some, like the shopping admin website, where basically the accuracy goes down. Overall, the API-based agent does quite a bit better than the GUI-based agent on its own, and then if we give it the ability to also use the GUI, then it improves a lot. So why is this? Maybe the answer is a little bit obvious, but if you look at the website, some of the websites have really good APIs, and some of the websites have really poor APIs. And so the places where you have really poor APIs, you tend to do worse. And so Reddit, or actually the Reddit clone we're using, Postmail, basically had really poor APIs. So one thing that we tried to do was we took the really poor APIs and we added a minimal number of additional APIs that did some of the really important things, like allowing you to upvote a post or other stuff like that. And that basically doubled our accuracy here. So what that means is if we make a pretty minimal effort in making better APIs for agents, that allows us to greatly improve our accuracy over the low accuracy. So if we make no effort with APIs, we basically match the existing accuracy. If we make some effort with APIs, we double the existing accuracy. So lesson number 3, I already kind of alluded to this when I was talking about what is driving improvements in agentic coding, but this is agentic training is essential. And the reason why is because the requirements of an agentic LM are very different than the requirements for a non-agentic LM. So a non-agentic LM, we basically need it to take in one response, answer questions, not hallucinate false information, other stuff like this. All of these things are good for an agentic LM too, of course. But I have basically 5 requirements that are particularly important. So the first one is instruction following ability. The agent must follow instructions, and it must continue to follow instructions when it gets a whole bunch of other junk in its context window from doing tool calls. And this is not something you can take for granted. A lot of language models will kind of forget what they had before. And so now, if you train models specifically to be good agents, then that will help resolve that. The second thing, I kind of conflated 2 things together here, so maybe actually these should be separate, but one is tool use. So it needs to be able to take in the description of a tool, and based on that description of the tool, accurately call the tool with the appropriate arguments. This is tricky. Another one is coding abilities. So specifically for coding, it needs to be able to write code in whatever programming language you're interested in. Another thing is environment understanding. So if you are building a UI-based agent or you're building a coding agent that creates a UI, it needs to be able to look at the UI and fully understand it. And to be honest, I don't think any LM that I've tried so far is actually adequate at doing this. And there's a couple things that I think all LMs are still not doing well. For example, they can't tell if something's missing in an image. So if I say, make sure that this UI is not missing any content, it will not be able to do that accurately. Another thing is they're very sensitive to small changes in interfaces. So they're bad at clicking buttons when the window size is smaller or bigger or something like this. So anyway, this is better than it was a while ago, but still a big issue. Another thing is error awareness and recovery ability. So about 6 months ago, almost every LM except Claude had this problem where if it made a mistake, it would continue making that mistake over and over again. So basically, it would get in a loop and it'd never be able to get out of that loop. Now most language models, or most serious language models are better at this because they've done agentic training, but this is a big thing as well. And the desired behavior there would be if you make a mistake, you try an alternative method. And then finally, reasonable cost. And so unfortunately, right now we have reasonable cost, really good language models like Claude Sonnet or GPT-5. We also have unreasonably cost, expensive models like Claude Opus. But we have a number of open models that are good as well. So how do we train agentic models? I'm going to introduce a few research papers that have 3 different methods for generating output, generating agentic trajectories that can be used to train models. So the first one is SWIGEM, which was done by Jia Yipan at Berkeley and Xingyao Wang at UIUC/Allhands. And basically, the idea was they set up a training environment where you have training examples, like an issue description in a code base, and unit tests that can give you a reward. And so what you do is you check, you have the agent generate an output, you generate a PR, you calculate the reward based on whether the unit tests passed or not, and then you do a gradient update. And you can do this either by generating a whole bunch and filtering out the ones that didn't pass unit tests and just keeping the best ones, or your favorite reinforcement learning algorithm like GRPO. The second one is generating synthetic data. And there's a lot of work on generating synthetic data for agents. I'm just highlighting this one because this was done by my student, and it's my talk, so I get to do that. But this is GoBrowse, and the basic idea is that we generate tasks synthetically by exploring a website. So we have a website, we have the agent explore the website and find different pages on the website. Then we have it guess what sorts of tasks a user might want to do on that website. And based on that, we then create trajectories to evaluate these tests. We create trajectories for these tasks. The core innovation of GoBrowse is that we continue exploring from the place where we left off. So it's not just like we explore from the same homepage every time, but we continue like better understanding the website. So this is just an example, and there's lots of other examples like this. So the final one is human demonstrations, and this was not by us, this was done by Google. It's a very nice data set called Android in the Wild, where they have 689,000 multi-step demos of how you can use Android. The reason why this was created by Google and not by us is because I don't have the money to hire people to create 689,000 multi-step demos, but if you have the resources to get people to help you out with trajectory creation, I think this is also a very good method. Okay, so what do we do with all this data? So the first thing that we could do, and which all of these papers do, is you take this data set and you train on it and you demonstrate that you do a better job at whatever task you care about. And that's great, but when I use a language model, I don't want to use a browsing language model and a coding language model and another language model. So one thing that we've done very recently, and hopefully we'll have a paper out on arXiv soon, is we gathered together a whole bunch of different available data sets, including all of the ones here that include tasks like coding, software engineering, API tool use, web browsing. And we developed something called the agent data protocol. And the basic idea is everybody, when they release an agent data set, it's a little bit different. Each one's kind of a unique snowflake in how it's formatted and all of these other things, which makes it really, really hard for you to train agents on this data. And so what we developed is we basically took all of these data sets and tried to come up with like the minimal set of underlying operators that you would need in order to express all of these data sets and not lose very much information. And so we take in the raw data, we put it through the agent data protocol, and we turn it into kind of a standardized format. And then based on this, we have converters that can convert this into formats that could be used to train different agents. So we could train OpenHands, we could train SWI agent, we could train Agent Lab, and all of these others. And basically, what we show in this paper is that by doing this, we are able to train models effectively. We're also able to achieve positive transfers. So we have some data sets that were like super highly tailored for being good at SWI-bench, for instance. And we get good results when we train on them. So for example, SWI-Smith is a data set that allows you to get very good results on SWI-bench, but we get even better results when we train a model on all of these data sets, demonstrating that we get cross-task transfer here. So another lesson that we've paid attention to more and more as I start deploying agents to people who are actually using them is that benchmarking must be ecologically valid. So like I think everybody knows and loves SWI-bench verified. It's a data set that a lot of people in industry are chasing after and trying to improve performance on, but it's only a small part of the story. In fact, I didn't put this on my slide, but software engineers only spend about 15 to 20% of their time coding, or at least 5 years ago, it was the case that people at Microsoft Research found that 15 to 20% of the time was spent coding. A lot of the other time was spent, debugging already written code, writing tests, writing documentation, talking to other people in the company, going to the bathroom, stuff like this. So what we want to do is we want to create benchmark data sets that cover the broad variety of things we'd like agents to be able to do. And so one thing is we're both blessed and cursed with benchmarks. This is an example of the OpenHands evaluation benchmarks directory where we have like 25 different benchmarks implemented. So we could theoretically be running evaluation on 25 different benchmarks every time a new language model came out. And 3 new language models came out in the last week or so, Sonnet 4.5, GLM 4.6, all of these things. And the people using OpenHands are saying, why haven't you tested this yet? And we could certainly test on all of these data sets, but it would be super expensive, super slow. Sometimes we break things and one of the benchmarks doesn't start working. So what we've decided is we want to pare this down to some data sets that really closely reflect the types of things that we would like people, like an agent, to be able to do when we're training an agent. And so the first thing is VersaBench. So it's a good benchmark. It tells us how well agents can code Python code, and also we don't want to remove it because everybody benchmarks it, and we want to know how well we're doing compared to other people. Other than that, we have several benchmarks regarding more fine-grained software engineering tasks. So the first one is a CI build repair benchmark. So this is a benchmark about repairing existing code. So when that code breaks, can the agent go in and fix it? We also have VersaBench commit 0. This is a really interesting benchmark about re-implementing entire libraries from scratch, given just the unit tests for the library. So at least theoretically, this should be possible. You just work until all the tests pass. But in reality, it's kind of hard for agents to do this well. Another one is VersaBench multimodal. So this is front-end programming. So it tests whether you're able to do JavaScript, understand GUIs, other things like that. Multi-VersaBench is a multilingual version of VersaBench with, I think, 9 programming languages like Java, JavaScript, C++, other things like this. And then my favorite, most underrated task is software testing. So SWT is, can you write unit tests to reproduce a bug? And the reason why I really like this one is because I feel like once you're able to write a good unit test to reproduce a bug, you basically have it solved. Like, agents can now fix unit tests quite well. I say basically, it might not be entirely, but agents can fix tests quite well, but they're really bad at like figuring out the core cause of a bug. And so this actually tests that ability, and it's really hard, but GPT-5 is actually really good at it. We also have 2 others that are not related to software. One is Gaia, which I already mentioned before. It's kind of a research-based benchmark. And then the Agent Company, which is a benchmark about being able to function in a software company, including web browsing, coding, other stuff like that. So we're expanding our benchmarking. Separately from this, we also have a paper that should be on archive very soon, I think, of evaluating agents with humans in the loop. And so we have a fair number of people using OpenHands through our online service. And so we wanted to know, are people enjoying this? And also are people enjoying it in a way that matches up with how our benchmarks work? And so what we did essentially is we gave the ability of users to give feedback on whether the interaction was good or not. And so this allows users to give feedback on like how well things are working. I think we designed this pretty well because actually 8 to 9% of users actually give us feedback, which I think is very high compared to a lot of other services. But still, it's only 8 to 9%. So we'd also like to know when things are going poorly, even if users don't give us feedback. And so another thing we did was we trained a model to take in various features of the conversation, including whether the user is sending lots of messages, whether the agent is taking particular actions like pushing to GitHub, and other things like that, extract features from this, and train a regressor to those ratings. So basically try to predict what the ratings are going to be. And then based on this, we can use both the actual feedback we get and the pseudo feedback that we calculated from here and predict whether one model is better than the other. And basically, this enabled comparison of different models and also allowing us to correlate human experience with benchmark scores. So we did a number of A/B tests where we basically had people use one version of the system or another version of the system across 3 categories. So the first one is varying the language model. The second one is varying planning. And then the third one is varying how much memory we use. And so I'm not going to talk about, I'll talk about this memory part later. But what we could see is that we got a significant improvement when we switched from Claude 3.7 to Claude 4, or when we compared Claude 3.7 and Claude 4. We got a significant decrease when we compared Claude 4 to GPT-5. We got a significant improvement when we showed plans, and we didn't see a significant difference when we varied memory. But The interesting thing is when we used the augmented ratings from like automatically predicting user feedback, we were able to get a significant difference more quickly. So we're able to assess, various design decisions more quickly based on this. And in the paper, which again should be out soon, maybe next week, we also have some analysis of like what features of the conversations were different as well. So another question is, how good are our benchmarks? And the answer is good and bad. So the first thing is when we compare Claude 3.7 and Claude 4 was generally better on many of the benchmarks from VersaBench, where we compared the different models using just these benchmarks. And there was a pretty high correlation between how much better Claude 4 was compared to how much better it got in like human feedback. However, when we compared GPT-5, GPT-5 was actually quite a bit better than Claude in a lot of cases on the benchmarks, and quite a bit worse in the human ratings in a lot of cases. So why might this be? I think the big reason is GPT-5 is really slow and not very verbose. So it takes a lot longer than Claude, and the users didn't like that as much. And also, it doesn't give as many verbose messages. So so there's other extraneous factors other than benchmark performance that factor into human perception of how well the model is doing. So another thing I'd like to talk about is handling under specificity. So SWE-bench verified is the benchmark that everybody uses to evaluate software agents. The verified in SWE-bench verified, what it stands for is that people at OpenAI had some programmers who went in and looked at the issue, and they said, okay, looking at this issue description, I can completely solve this issue and pass the unit tests with no ambiguity. So it's like all of these should be solvable only from the issue description, and then they removed all of the issues that weren't sufficiently specified. So this is great for benchmarking language models because if you don't remove these issues, your performance ceiling is going to be low because the issues are too vague for the language model to solve appropriately. So the performance ceiling for SWE-bench verified, at least theoretically, should be close to 100%, where for normal SWE-bench it's not. But on the other hand, if you look at what actual users say, they're like, yo, my code broke, tell me what's wrong. And they are definitely not well specified enough for you to figure it out without talking to them. So what we did in this paper, handling under specificity in software engineering, or something like that, you can search for the actual title, is we took SWE-bench verified, and then we made the issues intentionally vague. We used a language model to remove some of the core, important information. And once we did this, here on the right, we have SWE-bench verified, and then on the left, we have the results on the intentionally vague issues. So you can see that there's a huge drop of about, dropping half the accuracy. Then in addition to this, we also gave the language models the ability to ask users questions. And so we had a pseudo user that had access to the full issue with all the specified information. And based on this, the agent could interact, and we can see that it recovers about half of the loss, which means that it's pretty good at interacting with the user to try to figure out questions. Only after we tell it, you must ask questions, otherwise your success at this task depends on you asking enough questions. We had to really prod the language models to do this, but this allowed it to increase. However, it didn't increase all the way to the top. So you can see that we still don't have the full ability to resolve ambiguity. So a final thing is agents should adapt with us. Every programmer, or maybe more broadly, every agent user has a different way they want to interact with agents. And so we believe that agents should be able to learn from our experiences. And as you saw, I've used an agent 2,000 times, or probably more than that now, over the past year. And I'd like it to learn my ability, learn to be able to kind of match my preferences and stuff. So a typical way to do this, which is implemented in most coding agents nowadays, is to give some sort of customization instructions or rules to the agent. OpenHands does this through an idea called microagents. So these are basically either a customized instruction for how you deal with that user, how you deal with that repository, or how you deal in a certain situation. So like, for example, if somebody mentions GitHub, you can have a GitHub microagent that tells you how to interact with GitHub. But we'd like to also create these automatically. So we have a paper by one of my students, Zora Wang, called Agent Workflow Memory, where basically it looks this up. Daniel, did you talk about this by the way? Okay. So yeah, he talked about this. I'll skip over it. We also have agent skill induction, and basically this is a version of Agent Workflow Memory where you generate programs and not prompts. Did you talk about this one? I did. Okay, thank you. Yeah, Zora's our student, so, but yeah, my important, but the important thing here, I wanted to talk specifically about something I mentioned before, which is the interaction between APIs and versus web UIs. So one common criticism when I say we should be writing everything in code, we shouldn't be interacting with UIs, is, well, some websites only have a GUI. And so you don't have a good API for it. But you can create an API for it by learning functions to interact with the GUI. This is a last resort. Of course, you want a proper API to interact with the website because it can directly access the database. It can be more efficient and stuff like this. But I think basically we're, there are ways you can get around with this downside of GUI agents, of API-based agents. So yeah, that's my conclusion. Just a few forward-looking statements, and then maybe you can have a discussion. But I think all of these things are going to be really important. I have a lot of thoughts about safety, but I saw there's many people talking about safety here. So I figured I'd talk more on the agent building side. But it's super important. Credentialing agents, sandboxing agents is super important. I think also one of the really interesting implications of API-based agents is now, I think people are realizing more and more that agents are going to be interacting with the world, and we need to build a world that makes it easier for agents to interact with them. And so now one of the core challenges is language modeling still, but another one of the core challenges is how can we safely and effectively get the context that agents need into them through APIs, MCPs, whatever you want to call them, and allow for effective deployment, but also safe deployment. So yeah, that's another major challenge we're dealing with now, and we need good benchmarks for this, other stuff like that. So yeah, that's what I had. So thank you. I have a mic here also.
Oh, anyway, okay. What? Thanks. Thanks for a great talk, actually. I really much enjoyed. My question is, I want to react on something you said at the very beginning of the talk about the design of the agents, the fact that we may not need to actually use our prior about how the task should be conducted to guide the design of the agent. So I wanted to reflect on this, because if we're using agent to do software engineering tasks, we have a history of software developer doing the task in a certain ways. Do you think this should be used to guide the design of the agent, or we just remove all this prior knowledge and then try to optimize for the task?
I think you need a bit of prior knowledge, but I would say that the bit of prior knowledge that you need could mostly be captured through memory or additional tools and skills that you give to the agent. There are certainly things you want to customize. So like, for example, for security policies might go organization by organization. So like one organization might be okay with you accessing external websites. Another organization might be not okay with you accessing external websites. So there's things like that. But I think the basic agent infrastructure can be pretty simple because it mostly involves accessing tools. And I think by keeping it simple, this also has benefits in like training a language model with a single framework is easier than training a language model with like lots of different frameworks. And ensuring security is simpler if you have only one canonical way to access tools versus lots of different ways to access tools and things like that. So yeah, basically I think that's my current thinking anyway. Yeah.
Thanks for the presentation.
Yeah, if anyone wants to see the agentic summary of our workshop here, you can you can see it later. I'll share it with anybody who's interested.
Thanks for the presentation. I enjoyed the lessons very much. As you said, all the lessons are about capability. But even between capability and safety, there's the issue of trust. Because as you develop these agents to be capable for them to be put into production in some way, either they can be members of a team or they can be part of the workflow, maybe a new workflow. So one has to engender trust, maybe by giving explanations, which goes a little bit beyond safety, I feel, safety and security. So I wonder if you have some thoughts on that, and whether you could constrain the agent behaviors in some way in the invocation of the tools, or will it be that there will be new artifacts to engender such trust?
Yeah, it's a great question. So like there's so many different aspects to this question that it's going to be hard to answer comprehensively. But the first one is like visibility into what the agent is doing. So we have we have a UI here where you can watch what the agent is doing. So this is the first kind of pass at engendering trust, because at least it tells you what the agent is doing, and it's not like I have done this. One thing I forgot to mention is there's a lot of different ways to invoke these agents. So you can invoke them through GitHub, through Slack, through an API, other things like this. But every time you invoke the agent, you always get a link to this, so you can see what the agent is up to and ask follow-up questions, other stuff like that. The next thing is security. So our agent has a security policy enforced both by prompts and security analyzers. So the prompts are basically telling the language model, you should do these things, you should not do these things, and this is customizable, so you can pick what you want it to do and what you don't want it to do. We also support post hoc security analysis, so it's basically like every time the agent takes an action, you can analyze it and decide what the risk level is and stop ones that are high risk. So that's another thing. Then in terms of trust within the agent work quality, that is a big issue right now, because I think the agent work quality is still not high even with our best language models, or not consistently high even with our best language models. We're thinking about a number of ways to do this. The first thing we already have done is we have prompts. Like every time it sends a pull request to GitHub, we have a follow-up prompt before it sends it that says, please make sure that you've completely reflected all of the things in the original instruction and don't have any extra things that were not included in the original instruction. And then the agent goes back and double checks its work. And this can increase overall quality, but it's still not perfect. But I think there's further things that we could do. Like we could have, a specific checklist that checks off all of these things that says these are okay, these are not okay, other stuff like this. Oh, another thing, sorry, as I said, there's a lot of aspects to this. Another thing is knowing whether the task is doable in the first place. So we actually have a way to analyze a priori whether the task looks doable. And if the task looks doable, we give it like basically an ease level. So it's like easy, medium, or hard. And if it's hard, we give the user feedback about whether, about what places could be improved to make it easier for the agent to do a good job at. So we're doing a lot of little things, but I don't think any of them is a fundamental solution. Yeah.
Two of the things which are, even though we are all very excited about coding agents, and we all feel that, okay, coding agents are great, and they have reached the level of efficacy. Two things which are preventing them being put into production. One is the cognitive load of the agent outputs.
Yep.
It might even be negative, that's one. And the other is everyone is focusing, just like you said, and I completely SWE-bench efficacy. That means how much higher you can go. What you really need is that it would be lower efficacy, but whatever it says with confidence.
Yeah.
And that is currently completely missing from the research. So since you have spent so much time on open hands, I was hoping to kind of inquire.
Yeah, one thing we've wanted to do, but we haven't had time yet, is to measure the F measure on SWE-bench. So give the agent the ability to abstain when it thinks it's done a poor job. Unfortunately, there's a lot of things to do, and we haven't quite gotten to that one yet. But I think, yeah, giving it the ability to abstain is also a good idea.